Here we have a SAT math problem. Okay, let's go to the question. The lines with the equations y equals to 2/3 times x and y equals to 2x negative 8 are shown in the xy plane above. What is the area of triangle OPR? Okay, so we have to find the area of this triangle OPR. Okay, here if I want to get area of a triangle, we can use a formula that is 1 over 2 times base times height. So this is a formula where how to get area of a triangle. Okay, for this triangle OPR, so the base is given by the line segment OR over here. And also to get the height of this triangle, we can consider a vertical line segment over here. So this gives the height of the triangle, this line segment. Okay, now to get the base of the triangle, what I have to do is I have to get the x-coordinate at the point R. So for example, if I'm getting 6 as the x-coordinate at the point R, then we'll have the value 6 on the x-axis over here. Then the length of this line segment is 6. This is the base of the triangle is 6. Just for an example, I am saying 6, but I do not know, I have to find it. And also to get the height of the triangle, I have to get the y-coordinate at the point P. For example, I am saying the y-coordinate at point P is 7. Then we'll have the value 7 on the y-axis over here. So clearly the length of this line segment is 7. So that's the height of this triangle. So okay, now our aim is to get the point R and also point Q, particularly x-coordinate at the point R and y-coordinate at the point P. Okay, now first let's find the x-coordinate at the point R. Actually, this point R is the x-intercept of the line y equals to 2x negative 8 because this is a point at where this line intersects x-axis. Okay, since this is the x-intercept, what we have to do is we have to plug in y equals to 0 into the equation to get the x-coordinate. Okay, now let me take this equation as it is. Y equals to 2x negative 8. Okay, now let me plug in y equals to 0 here. Then I'm getting 0 equals to 2x negative 8. Okay, now let me add 8 to both sides. When I do so, this negative 8 positive 8 will cancel out. On the left side, I'm getting 0 positive 8, that is 8 equals to 2x. Let me divide both sides of the equation by 2. Then this 2 will cancel out. 8 divided by 2 is 4. On the right side, we get x. Okay, now in this equation, when I plug in y equals to 0, I am getting x equals to 4. So the point is 4 comma 0. That's a x-intercept. So that's a point of our 4 comma 0. Okay, since the x-coordinate of the point R is 4, we have the value 4 on the x-axis over here. Now then clearly the length of the line segment OR is just 4 units. That is the base of the triangle. Okay, now we got the base of the triangle. Still we have to get the height of the triangle. For that we have to get the y-coordinate at the point P, as I said earlier. Okay, now to get the y-coordinate at the point P, what we have to do is we have to solve the two equations we have over here. Because P is the point of intersection of the two lines. Now to get the x-coordinate and y-coordinates of the point P, we have to solve the given two equations. For that, let me write y equals to y. Now, for the y on the left side over here, we can consider the stuff in this equation y equals to 2x negative 8. That is, we can plug in this 2x negative 8 for the y on the left side over here. Then I'm getting 2x negative 8 on the left side. And for the y on the right side, we can consider this equation. That is, we have to plug in this 2/3 times x for this y over here on the right side. Then I'm getting 2 over 3 times x. Okay, now to get rid of the denominator 3 on the right side, let me multiply both sides of the equation by 3. Then I'm getting 3 times 2x negative 8 equals to 3 times 2/3 x. Okay, here this 3 will cancel out. Now we can distribute this 3 to 2x and negative 8. Then I'm getting 6x negative 24 equals to 2x. Okay, now let me subtract 2x from both sides and also let me add 24 to both sides. Let me do it. When I do so, this negative 24, positive 24 will cancel out. Positive 2x, negative 2x will cancel out. So when I combine 6x and negative 2x, I'm getting a positive 4x. On the right side, we have positive 24. Okay, now let me divide both sides of the equation by 4. When I do so, this 4 will cancel out. I'm getting x equals to 6. Now I got the x-coordinate at the point P, that is 6. Now to get the y-coordinate at the point P, we have to plug in x equals to 6, either into this equation or this equation. Okay, let me plug in x equals to 6 into this equation. Then I'm getting y equals to 2 over 3 times. So for this x, we can plug in this 6 over here. Then 3 goes into 3 one times and 3 goes into 6 two times. Then I'm getting y equals to 2 times 2 is 4. Okay, now I got the y-coordinate at the point P. So finally the point P is 6 comma 4. Since the y-coordinate over here is 4, then the value we have on the y-axis over here is 4. And the length of the line segment I have drawn over here is 4. So this is the height of the triangle. Okay, already we got the base of the triangle, that is 4. Now I got the height of the triangle, that is also 4. Okay, now let's get the area of triangle OPR. So the formula is, as I said already, 1 over 2 times a base times height. Okay, here 1 over 2 times the base of the triangle is 4 and the height of the triangle is also the same 4. Here 2 goes into 2 one times and 2 goes into 4 2 times. Now let's multiply this 1 and 2. That is 1 times 2 is 2, 2 times 4 is 8. Therefore, the area of triangle OPR is 8 square units.